And we are live, and I have my microphone halfway across the galaxy. Okay. Let's get that barely out of frame and right in front of my light so it casts a shadow over me. Alright. Hello everybody. Welcome to my descent into madness. You are currently joining late. I have been at this for like 8 hours today already. Like, I started coding, actually no, more than 8 hours. I've been coding since like 9 p.m. yesterday. Yeah, and I haven't stopped, and I'm like, you know what? I am not sleeping until this is working. Because it's driving me insane, and should be simple. Because I'm writing, like, genuinely, like, a should be pretty simple compiler. Let me show you the height of madness here, actually. We're gonna record this forever as the height of madness. Boom. It is now recorded. So if you check the Discord or like just the GitHub, that is now recorded as the height of madness. Hello, welcome to the madness. Yeah, so what I wrote over the last, I want to say 8-9ish hours is I had this idea that we would walk over the AST of the program. Let's see, where is it? Yeah, so if we go to compile context here, we would walk over all of the AST. You'd have this emit statement and evaluate expression nodes, and what the expression node expression walking would emit. Same. I also have not woken up early. We've been up since before the sun went down. Yeah. But yeah, so I think I figured out why I've always struggled with this concept that I put in the title of the stream, which is L values versus R values. Now, what do those completely random words mean? So, in C++, let's say you have int a is equal to 0, for instance. And let's say we also say a is equal to 2. In this case, a is an R value because it is on the right hand side of a assignment operator, and 2 is a, did I say R value? No, it's an L value. It's an L value because it's on the left hand side of an assignment operator. And 2 is an R value because it is on the right hand side. Now, I think I get them mixed up because I'm like, R, it's the correct, it's like, yeah. Anyways, basically an L value is, explained better, is any variable that has an actual memory location backing it up. So if a piece of memory is on a stack or on the heap, it is an L value. Now, you might be saying, you just named the only two places to store variables, the stack or the heap. There is nowhere else. But you're wrong. There's a different place to store variables, and that is registers. And registers, you can't have pointers to values in registers. So, in the case of this 2 technically could have a memory address, because this is probably stored somewhere in program space as a constant variable in like some blob of memory. However, let's ignore that. It's not anywhere directly exposed to your program. It's like a temporary value. It's not tied to any actual variable. So if we tried to make a pointer to this using the ampersand syntax, there's nowhere for the pointer to point to, so this will throw an error. And the error that it throws, at least in C++, maybe in C2, I think the stuff, yeah, .data, exactly. But like, from the syntax of a language, we're not taking into account that this is actually stored somewhere. Unless you're Rust with a string, or yeah, a string slice, which those have a static lifetime because they are blah, blah, blah. Anyways, or I guess C with string pointers, but that's the only place where you actually get pointers to literals. Anyway, this is an R value. You can't make a pointer to it. Yeah. But now, the thing is, programming languages let you do fun things, like chain these operators. And I have not figured out how to handle just like willy-nilly, like, see, this is a pointer. But now we're assigning the value of the pointer. But it's still the same value there. The only thing different about it is we're retargeting where we want the actual value to end up. And in the past of like 5 years at this point of making scripting languages, I have not like figured out how to solve that problem. And I've figured out why I have not been able to solve that problem. It's because I always try to walk my AST with the same exact and return the same exact value, regardless, the same format of value, regardless of the actual syntax of the program. So whether this is a dereferenced A or an A, whether this is an L value or an R value, pointer, dereferenced pointer, all of that stuff, the thing that I would return from that is some form of amorphous value that usually would contain a reference to the intermediate representation. Would usually contain a, like, some IR operations that were required to, like, I would have just emitted the IR for the operations further up the tree of that expression, and then like instructions have already been emitted, so I have to work with kind of whatever's left over after that. So now if this wants to be dereferenced, I would actually, my first version of Brane script v1 didn't have the concept of recursive pointers, and every single variable had a isDref boolean just like paired with the value, so I could tell if the value was dereferenced or not. There are many things wrong with that version of Brane script, and that was probably the most wrong thing. Then with Brane script 2.0, which was when I went to like functional programming, right? With functional programming, you don't actually know where the values are getting stored, so you can just completely ignore L values versus R values, and that's partially why I really liked doing L values versus R, like that's why I really liked functional programming, was because I didn't have to deal with L values versus R values. I could just like choose my own grammar and not deal with this thing that like programmers are used to of like values subtly changing how they act behind the scenes. However, now we're making a C clone because it's easy to make a C clone. And like, think I could get something compiling by the end of the day, if I don't crash out and sleep for 8 hours. Or longer at this point. So, we're taking full advantage of the Mania episode, and continuing forth. Basically, what I have discovered is probably the solution is I just do what I want to do. I walk through my program in a single pass, just like I really like doing. Happy 4 in the morning. I also forgot to sleep, and it is 7 a.m. in the morning. But, yes, what we do is, instead of having one function to walk the AST, instead, we're going to have 3 functions to walk the AST. Each one is going to walk the AST in a subtly different way, because each one will return different things from the way that they evaluate. And they'll all call like each other. It's not like we have one completely independent recursive walk of the tree and a different completely independent recursive walk of the tree. Instead, it's just kind of like, do I need an L value for this current operation? Call the evaluate expression as L value walking, or call it as R value walking, or this is the important third one, as callable, since I have the concept of intrinsic functions, which could just be IR operations. And yeah, to kind of reiterate the madness that I was coding, and I took a breath up for air, and I'm like, this is madness, and then I started recreating the madness again. I basically created this value kind thing, which the idea I had was that it would lazily emit IR depending on what expressions needed. So instead of just walking the tree in different ways, you would have this value struct, and then on this value struct returned from the walking operation, you could get SSA value, which is essentially a R value. You could get SSA pointer, which is essentially an L value, or you can get value path, or as callable was the third one. Value path is a way to deal with me not wanting to do phi nodes, which is a different thing that I have to just come to terms with, that we're gonna have to do a post-processing pass on the module to call any phi nodes that don't actually need to be there. So yeah, basically we just have to copy kind of what we were doing here, but it's going to be a lot easier because we are no longer lazily emitting values, we're just emitting the values directly, which means, and this is also why I committed my code to have a store, because what I'm going to do is just nuke everything. Because you know what else I did? I created an entirely different type structure. And the original purpose of this was because I couldn't store the type of pointers, or slices, or tuples, or any of those things. But the thing is, I don't actually need to really care about the difference between those things now, because I did reformat, I did refactor the IR to handle pointers, and actually store the type of pointers. We have typed pointers in our intermediate representation now, which is nice. It's a good convenience. We don't really need it, but it's a very good convenience, and it's good for when we eventually do reflection-esque things. Oh. Yeah. So basically, since the intermediate representation itself can now represent everything we need to know about types, we don't need this new representation of types. And since we're emitting everything immediately, we don't need the new version of... Yeah, so after I did the madness that was that lazy IR emitting, I'm like, this is crazy. what if I just like slim it down to like closures that we emit after the fact, so that I can handle fine node culling at this level and then just lazily emit that. So this was the crazy solution that was attempting to fix the other crazy solution. And then I realized this is also a crazy solution, and we're not going to do it. So let me stop talking about being crazy. And we're just going to... Can I just do end? No. We just deleted like 500 lines of code there. Let's go. Don't need this either. We do want values. Crazy solution is always the best solution. See, I need to leave myself bandwidth to be crazy with the engine instead of with the scripting language, which is the current something. I lost the ability to speak there. Been up too long. Indeed, especially in the early hours of the day. Well, for me, it's the very late hours of the day. We going crazy. Okay. We no longer need emit type. I wonder, can I just... So we have this emit type function that we don't need anymore that is absolutely massive. This is actually an amazing opportunity. To just have the intern do it. We're trying to figure out how to actually use this efficiently, because so far AI has only slowed me down, which could be a good thing. It could be a skill issue. It's like either very much not a skill issue or a skill issue, and it's like the thing that does stuff for you is really bad at doing stuff for me. So either I'm bad at telling it what to do, or is bad at doing what I'm telling it what to do. I mean, I did tell it to make a function recursive 5 times earlier in the night, and every single time it did not make the function recursive and absolutely, like, did not comprehend what I was telling it to do, even though I gave it a paragraph like that long of what I wanted it to do, and it's like, no, we'll account for the base case, and not for if it's actually recursive. And I'm like, the entire point of this is that it's recursive. Anyways, I needed to merge this emit type function with the resolve type function, because resolve type turns from an AST type into that old type definition that we've since deleted, but we want to go straight to an IR type. So I am simplifying my code, and I've deleted the type struct. So I would like deleted an intermediate type struct. And I'm not actually sure which model this is using, because like I manually switched it to 4.0 several sessions ago. I don't know if it saves that. My profile by default has it set to ChatGPT 5, but it's been like not great at reasoning. So I'm wondering, maybe I need to set it to like ChatGPT 5 thinking, because I have heard that like the default model is kind of crappy. Actually, no. ChatGPT 5-chat is the one that they do chat that like is the dumb one. I don't know. Anyway, it will be good enough for this, hopefully. Intermediate TY struct. But I still have just run locally like a normal person. I can do that. In fact, it's hooked up. I could literally switch like Avante switch provider right now to my local. Which one is it? Not Claude Code. It is Quencoder 2.5 that I have locally set up. Anyways, the API is a lot faster. I'm trying to like figure out the actual usable things. So, simplifying my code, and I've deleted an intermediate type struct. So I want to merge the emit type and resolve type functions. Rename resolve type to emit type, and then make it output what emit type outputs by merging the two function bodies and removing the intermediate type. This really shouldn't be too hard for it. Well, it's taking me literally, and first, just renaming the function. Okay, let's see. It yeah, it didn't merge them. I'm just gonna try it. Please try again. And this time, actually merge the function bodies. Like, this should be simple, right? There we go. That looks correct. Kind of. Okay, it looks like it has. How do people vibe code? It looks like a pain in the basket. Wait, get it to do what you want to do, let alone basically write an entire project. I'll tell you, they're web devs. They're working on web code where the vast majority of what they're writing is boilerplate. It was actually correct. No, actually, I don't want it to do... Well, actually, since I deleted value, it's fine for it to directly import that, I guess. But, yeah, the thing is, basically, to my understanding, vibe coding works a lot better just, like, in JavaScript code bases, since that's the vast majority of, like, code that makes money is JavaScript and websites. Indeed. If basically they just write UIs and like follow design documents. But here's the thing. If they're not the ones making the design documents and all they're doing is implementing, that's a great place for like automation to come in. And that's like if they're not doing anything innovative, which like the vast majority of React the React code bases aren't like super cutting edge. And no matter how cool your calculator is. Okay, so like it messed around with my imports. Did it actually? So it did good on this. Like we actually like let's pull out cargo check, see if it detects anything aside from formatting errors. Doesn't struggle with creative and non-standard stuff. Exactly. AST, abstract syntax tree. So once you parse your code, you basically turn it into a tree data structure that is basically exactly the same structure as your code, but it takes into account stuff like operator, precedence, and all of that. So instead of like manually parsing out a string, instead now you just have like a what expression is this, and then you can match on it, and it's like, this is this function call, or this is this type of expression. Basically, I can give a good example here. AST type, some of the types is like, here's all like the native types. So anywhere where you'd have I8, it would have been turned into this enum variant. So it's a lot easier to work with than just like a string. It also like contains like source data in an easy format, so if I want to omit like fancy errors, I can just go like self emitter. Actually I think it's like emit dot log, yeah, and that's how I start my fancy error messages. And then I can add like annotations in the code, and you just throw in the source here, you say is this an error, and then like give a fancy message to show next to that block of code, which is very fun. Very tedious, but it looks really cool. Oh, I was talking to a YouTube chat, so I'm multi-streaming right now, so there's like one guy talking in YouTube chat and one guy talking in Twitch chat right now. So I have double the voices in my head than usual. Yeah. GLSL macros. Oh my. GLSL macros, just C macros. Okay, so this delimiter, it did something wonky with the delimiters. We're gonna have to manually merge these functions. I was like hoping, because that's like I could probably just the funny thing is, I know that I could probably copy and paste this into a text prompt, and it would probably do it fine. But for some reason, the agentic version of it, agentic, is significantly less good at its job. Wait a second, did this? Wait, this might have actually worked. It looks like module context emit type. Wait a second. It did work. Here's our merged function. It's just in a different part of the document than the other definition of it. Actually, it does make sense for it to be a member of the module context. Yeah, I'm gonna keep it there and hope that it is... No, we'll go read it. We'll go read it. I won't be lazy. What made you do in Rust? Fancy matchers? Yeah, I really like Rust style enums. Discriminated unions. To the point where, like, I'm making the simplest possible language for my game engine. No more, like, dependent types and fanciness and huge amounts of static validation. No, we're just going to make something that works. So we're going to copy the functionality of C, but with Rust syntax, because that's what I am currently brain rotted to. And we're going to add in discriminated unions. I'm just like, they're too good. I have to put them in. Now I have to make, like, fancy switch statements. Well, match. I'm calling them match statements, just like. But they're a switch statement that can also do enums. But no, I'm like, it's as simple as possible. But we'll throw in enums. Okay. I am scrolling around like a madman. So, st type. Print script will use Rust syntax. Very loosely, yeah. I'm kind of split on it. I haven't like fully locked down the syntax yet. Don't worry, we have structure. We have structs. So what this actually wants to match on is TUI kind. Like that. Structures with methods. It will look like the structures have methods. They're actually global namespace functions, but the syntax makes you think that they're methods. But the thing is, I want to avoid any form of fanciness at the moment. And member function calls are just the slightest bit of fancy. I basically told myself, no syntax sugar whatsoever. And in my opinion, member function calls are syntax sugar. That might be a hot take, I'm not sure. How's enum not a valid type here? Oh, because it's path. It's because it's path, that's why. Yeah, and this is where you'd want to reference the other function. As it works. As long as it works. Okay, how did I define this? So this is an anonymous structure, which I'm not sure if I'm keeping or not, but like, you have anonymous structures if you want them currently, because they're not too hard to add. Struct number, field name, text, clone. ID is none. Yeah, because this is anonymous struct. Okay, and then I want to keep the code for enum here. The code for slice as well. Everything by copy. So here's the thing, where is the copy stored? Is it an L value or an R value? Especially, so because of the way my intermediate representation works, and the fact that this is like a sandbox scripting language, I don't actually have a stack that I can pass pointers to. Like there's implicitly the stack that registers overflow into that the backend handles, but there isn't actually the ability to make pointers to values on the stack. So essentially, I have two types of values, I'm calling them SSA values, or you know, like R values, or you have L values, which are all stored on the heap. There is no stack. Now, would I be able to, in my runtime, handle like binding pages of stack, and then handling like a separate stack pointer outside of the like actual existing stack pointer? Yes, that is something I could do. Is that something I want to deal with? No. So instead, just a language without a stack. Though it'll look like it has a stack and feel like it has a stack, but it won't. Okay, Brane, work with me here. So why am I creating new AST values here instead of just doing like... Inner type is an option, so we're gonna map inner type. Into an IR value. I think that just works. Is this a result? It is. So we need to figure out a way to get that result out of there. Easiest solution is just to like nice. Do it the hard way. Which way is the hard way? Okay, so the emitted pointer type is just IR type pointer, and it is an option. I'm gonna make this mutable and then inner type. Boom! We don't have to unwrap the option. Okay, we're good. Memory alak. And then for the length type, just native type U64, we can do that. Fire type native. Not AST. IR native type U64, because this is a wide pointer. So technically this pointer is 32 bits, which means this could should also be 32 bits. Which means we no longer need that. Get out of here. Nice. And then where is string? Actually, I'm going to use a self emit type, and then we're just going to pass in a type slice. Of course, I'm not going to get any error checking until this block of code ceases. Oh, of course, it needs to be a type reference. You know what? Fine. I'll just have the code copied. Then the inner type is going to be iron. Native type U32, because that is what character is. Yeah. Because Unicode. What else do you want? Okay, it wants this to be an option box. Some box. New. There we go. And then let's just inline it. Not the macro. Okay, I'm gonna keep this multiple lines. Then we're back to enum, and that is because we're not currently accounting for path. Why is it not mad at us? Maybe because enum not real? So because enum not real, not angry about not having real ones. Correct. So now we have path, and this is where we go and put this emit type function back onto the module context instead of, the compile context instead of on the module context. As convenient as that is, the truth is that we need access to to compile context functions and yeah. All we need to do is search for everything that's self module, replace all of those with just module. And now we have a couple. It still exists. We need to fix our recursive references. Oh, wait a second. we need to actually reference the module in module context. So let's change this back to ctx context module. Context module. This needs a reference to context. This needs a reference to context. This needs to be context instead of self. This needs context, 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 and finally, but certainly not least, context. Now, where was I? Because I do not remember. Indeed, indeed. I need my context hat. Right, I was just about to add path. So the fun thing about path is it's a path. So we need to resolve what the path is. Hopefully, the path is a type. And that was the part of Brane, work with me here. That was the part of the old emit type function that was good. So here's what we can do. Don't know how the correct way to turn deffing off, but okay, we are on that page. So here we have resolve type, and in here I am just going to blatantly copy the path section of this. Which I'm actually not sure. We'll use this special keybind. There we go. So I think this will give us a very good template to start with. This is probably gonna fail spectacularly. And it does. Okay. Yeah. Basically, let's go to this struct. Where the only difference between this struct here and this struct here. Okay. I'm actually going to go and copy the entire one. Okay, yeah. There we go. Entire match statement there, like that. And then we do have fields. That are defined exactly how we would expect them to be. Oh yeah, and that's another thing, is I'm gonna have to deal with template parameters eventually. That's gonna be fun. Field type already is a reference. Now we just need to deal with enum, which we already have an implementation for. Did I delete it? Yeah, I deleted it. I could have sworn I copied it. Or like commented it. No way, I just delete it, right? Okay. I'm gonna pull from the struct. And oh, one last thing I need to do is the struct ID must be some s ident text. Whoa. Nice. And I'm gonna copy that little line of code for enum as well. Emitted variance, specifically This is true. Instead of ID being variable, instead it's the value is variable. So we're gonna say field type map self emit type context. Ooh, but that has a I really do like that inline. We should have formatted it slightly better. Now we have a list of enum variants. Get our E. Let's go over enum. Oh. Enums, enumerate. Variants is equal to emitted variants. And ID equals ID. Did I let enum IDs be optional? Apparently I did. I don't know why though. Okay. This is enum index. This is not an IR struct, this is an IR enum. Enums. Self, but it's already borrowed. By what? Self-resolve definition. Ooh. I don't want to copy it just to appease the borrow checker, right? Wait a second. Does self need to be mutable? Since all our mutation is happening in the module context. As long as resolve def doesn't need to load new modules, I think we're good to have this be an immutable method, immutable self method. That does seem to fix the issue. We're good. Enum. Let me just double check that the enum module enums push enum index type enum. That's a good catch. And also right here. Okay, so we now just straight up emit enums when we need to. And that's all good. We don't need value cache anymore, or expression count. We do need fine nodes. Which we don't need for the first IR block, but we will for blocks following that. Potentially. You know what? I will set a current block. Zero. Yeah. Guess it's time to start working on. Do we want to set Brane, work with me here. Do we want to reconstruct emit function? Yeah. Yes, we do want to resolve reconstruct. Fix reconstruct function. Restore reconstruct function. Why is this complaining? Ah. And then we don't need to do this mapping anymore. Oh, I do need to map this one. Okay, I can just throw this in there as IR value. That was my old, like, lazy emission syntax. Probably do want to store type value for stuff, though. That seems like a good idea, to make sure types are the same. Because I kind of want it to be an AST type. Then again, the paths would be different. Well, I'm not caring about debug messages right now. We're just trying to get it to compile. We can do a pass and do like amazing debug info later. Because I've set up the architecture for the amazing debug messages. So we just need to get to the point where like we have code to debug. But I think type information is important, so we're gonna throw type information in there. Yippee! So now we just do self emit block. Which is where we get to for statement in code block statements. Self emit. Emit statement context. And now here, an hour into the stream, we've gone to the meat of the matter, which is L values, R values, and the madness that is about to ensue. Or the clarity. The clarity would be pretty nice. But probably madness. So there is one thing I am undecided on, which is how to handle specifically I need my brain to work with me here. Do not need cheap viewers. I need expensive viewers. Okay, so now I need to define what is returned from these three functions. L values, R values, and callables. So with callables, we have the obvious intrinsic function. There's just going to be a reference counted dynamic function that takes in a vec of IR value. Actually, I'm going to say a vector of L value. And then returns L value. Result. Option L value. That's the thing. It doesn't necessarily need to return a value. It's just something I need to account for in the actual emit functions, because there are occasionally times when we just need to emit an R value. Right value is the temporary one. Need to remember L value is a value corresponding the location of a value or variable. And this or variable is important. FL value. These actually need to be R values. Now, our values are super easy. It's just value Val values are easy. It's just this is the pointer to the value. This is the memory address. But here's the thing. Because I don't have a stack, I have to handle SSA form values for everything. Now, users are probably going to be pretty annoyed if I force them to pointer, like, heap allocate their structures, which means I need to make it look like I can stack allocate structures. Now, to actually reference them, you will have to pointer out, like, malloc them. But, like, to just, you know, or settable value. Is with a memory address or a settable value. So this means this is a variable. This is a runtime memory address. This is a compile time variable. Compile time variable or emulated structure. Okay. Which means what I need this needs to be R value. variables will only ever represent what could be represented as R values since a pointer can be, yes, a pointer can be an R value, but it can be dereferenced to become an L value. Yeah. So variables are all R values, I guess. Implicitly. All of them. But here's the thing, I don't want this to ever be emitted, because that means that we have extra instructions being emitted. Does this need to store type values? Type checking? Since we can't derive that from the AST. Think maybe? Yeah. I guess the struct itself doesn't exist, so it doesn't have a type? But if we want to allocate it, then it does have a type. Technically. We have our variable. Wait to access our variable. Can I competently create and use this variable path? I believe yes. Actually, no, we'll have this explicitly be struct. And then we'll explicitly have a, you know, okay. Fine with me just throwing partial equal on there. But type. Yeah, that has all the equals. Okay. Are our values only ever going to be just straight up values? At the moment, it's looking like possibly. I'm going to keep this as a type just in case I find a use case where it makes sense to have our values be something different. Okay, but it is good that this is looking significantly simpler than my last attempt at this, which bodes very well. Brane turned off. Where are we? I think emit R value is the least committal one. We just do emit R value. This is so cheesy. It's a completely empty function just to change the return type. The better solution to this is just throw an OK at the end of that. And then just Be like, yeah. Okay. And now assignments. Syntax for this is quite easy now. We just do I think we evaluate the destination first. Let destination, oh, we'll say D. Let D equal self emit, and we want this to be a left value. And yes, I am using my hands to remember which one of these is which. Compiler development. There we go. Less errors to deal with. Mean expected result. You don't expect a result. I put an OK right there. Oh, it's because of this one. Because of you. Okay. Now that we have a destination, and this is great. I can just ask for what I want instead of like retroactively working with what I'm given. It's like life parallels there. No. So what we need to do is match on L value, which should be returning that L values enum. There we go. That's a lot more workable. So if this is a pointer, then we want to emit a IR operation store. And we want to store into pointer our source. Oh, and we need the context current block. I'll actually throw that into the emit function itself to grab the current block. Is like really easy. Suspiciously so. Okay, and then if we have a variable, then what we need to do is oh, wait a second. I have variable. I'm actually going to rename this just variables. Keep everything consistent. Okay, so if we've already found a destination, then we want to match on destination. else we want to check self variables get mutably this particular path segment. Okay, or else anyhow. Not use on variable path. Path join with the period. And we're gonna say destination equals sum this. There we go. Okay. So I need a good way to do so we need different variable path segments. I'm gonna say label. Which label should always be the base path segment. Struct field. Enum variant. Actually, I'm gonna say enum data. Because enum has enum variant. Actually, enum. This is the current enum variant that the enum is. Then we need option variable. Enum data variant index enum def. Okay. Enum data, enum variant data variant because we want to be able to differentiate between, like, because what enum variant is this? Is an actual value that we will need to grab occasionally. This is an SSA form enum. We don't know this at compile time. So this is what variant is contained by this. And you don't know that at compile time, but we will have to treat it as such. Like, we need to treat it like we are not sure what it is. Well, because we don't actually know what it is. I'm not doing dependent types anymore. You're not doing dependent types. You know nothing about the runtime values. There is no constant folding. There is no constant folding. There is no constant folding. There's no constant folding. Until we do, like, optimizer pre-passes or something like that. Post-passes. I don't know. I've been up too long. Stay up for 3 more hours and I'll have been up for 24 hours. Ramblings of a madman, indeed. Okay, I think the path segments make sense. Variable path segment. Okay. So now here, we stay up too late indeed. This is actually one thing. Implement display for variable path segment. This is one thing it's actually really good at. Boom. Done. Actually, this would be it. I already generated it. It's fine. Match segment. Why broken? Ah, invalid syntax. Delete. Fill. Give syntax highlighting. Begone errors. Let me fill the match statement. Dang it. It's not this. Oh. Variable path segment. Now it is correct. And now we can fill match arms. So in here, we need to say is sum. Technically, these could just be panics, but we're being overly rustation. Because it's not strings, we can't use join. And we implement? Well, actually. We'll just implement debug. Make our lives easier. Okay, so if destination is sum, fail because we don't think that should ever happen. If it is none, then we do destination equals this statement here. Self variables. Here, I'm just gonna say if path is empty, then parallel path was empty. Don't need this else statement anymore because we have consumed it. Wait, am I gonna run to borrow checker funkiness with this? Probably. I wanted to just get like references to stuff. Unless I just get, well, It's gonna go like first middle reference, second middle reference. It's not gonna like that. But we're not. Doth the borrow checker complain? It doth not. We should be safe to unwrap here. Very safe to unwrap here. Destination unwrap equals variable. Like that. So I think this currently would account for just the label. If we do struct field, we can do match on there's a special syntax I can use for this. Let dest, no, not, we'll say D. No, say root is equal to, let some root is equal to dest else. This is like some funky Rust syntax. Then we can do some control flow, bail, not resolve, path, must have label as root. And I'm actually gonna throw this check into every single one of, actually with, yeah. You throw this check onto all of them. To be clear, none of these error messages should ever fire if we use the system correctly. We are just having fun implementing all of them. Struct fields. Find all bugs. Can we? True. This will make it really easy to debug if it does bug. But new root equal fields, iterator, find, I think it's label and then value. We're gonna make this a find map. That's a find map. Label is a string reference, value is a box variable. So if label equals field, some value as moot, else none. Is a bar checker cool with it? Need an iterator mutable. Bar checker cool with it? Bar checker seems to be cool with it. I don't know. Yeah, this is the type of function I tried to get the agent, the intern, to code 5 times, and it was having none of it. It was like 1 level of recursion. That's all you'll get. Of course, I'm not using recursion here. I'm using iterative programming. I think that's the term for that. But you know, enum data. Now we get to swap these two. Data. Actually, this... Oh, it is box, so we do need to map it. And the unwrap will be a good check there. Enum data. Oh, enum variant is the ID of the enum. So we're gonna just copy the entire enum data segment. So then we get the variant value. Oh dang, the internet just got up? No. Oh, my phone just died, that's why. I'm listening to music on this earbud this entire time. It's like, what happened? Because like it disconnected and I was like very confused by that. How dry is my hair? Because I took a shower before starting the stream. So my hair's like all wet. Ah. Data is equal to variant. Variant as moot. Just stick with variable and then have value. Actually with enum variant and enum. Not with enum data, since that could be part of a larger path. But with enum variant specifically, we can set variant We're going in and assert here that type is equal to our type native IR native type. It needs to be equal to one of the integer types, but I do make it variably sized. Validate type. As moot. You reference. Variable found value. We know exactly what this should be. There we go. I'm gonna put a return there just in case. Okay, so all of that is recursive as it should be, and then we set the value. Okay. I have no clue if that's gonna work how I expect it to. But if it does, that would be pretty cool. Cool. Now, if this is a variable, we just do context set at path items. I guess an R value can be a variable. Value structure enum. All right. Man, the submit type function is massive. IR function arg r value. Match theming, could you not? I'm trying to like do a thing. Okay, I'm gonna have to create a function for storing things because we do essentially need to create a memcopy function instead of just emitting one store operation. Because if we have yeah. Oop. We have an enum. Potentially need to memcopy that enum. Piece by piece. Water reminder. Thank you. This water bottle sabotages me. Okay. That's what I get for taking the straw out. Expected value. No, you didn't. No, you didn't expect value. I'm gonna do self store, which takes in value, an R value, and the current function context. Yeah. Alright, and the reason I'm doing this is because since we have R values that are potentially the SSA form of structures or enums, that means that we need to be able to store those types, potentially. I guess I just put this match statement in there. Self store see, like, this seems too clean. Why is this so clean? Why have I never coded a compiler like this? I would have had Brane script working a long time ago. Okay. So if this is a pointer, we need to match on the R value. Why doesn't it like this? Maybe it's because we forget to set return value of despair? Yeah. Okay, so if this is a value, alright, have good sleep. Sleep is the thing I should be doing, but I'm not. Alright, if this is just a raw value, then we can just go ahead and store it. Here what we need to do is can I recursively call store? I think I can recursively call store here. Here's what we do. Since we have... Wait a second. is we have the IR struct directly embedded in this value. Amazing. Thank you, past me. That means we can do context, mod context. Well, type, layout, then we do context, mod context. To get the layout of the structure, module. Okay, I'm going to do a it element. I'm gonna create a helper function for this. Get struct field. Then I will do it by index for now. So what is items again? Variable path segment. Match on. Guess this has to get function context if I want this to be generic. Okay, it does need to be generic. We want to match. We don't want to match for this one. For this one, we do want to match on context. Set variable at path. Do we have get variable at path? Gonna just do get struct at path. Not get struct, get at path. We're gonna get a mutable variable reference from that. I'm gonna actually have this be not mutable. It's gonna be copy. It's gonna be an R value. Oh, right. I have member variables I can look at, so I can say type, layout, self module context, index type, the IR type, native type, Nice. And then this is what I should be validating on the other one, is that it is this type. We're casting it to that type. Probably survive. In most cases, probably survive. Okay, everything is now clonable. Okay. So we now have a way to get. Never mind. Okay, and now we have store, struct field, match, context, variable at path, items. Now that we have an actual struct, we can just return items, iterator, find, map, label, value, if label equals, oh wait a second. And we really just need to check if it's there at all. And then what we actually want to return is a L value. Want to do the field path. And we do want to do the checking, like the validation. Here, I think, maybe? Not really in the utility. variables. Items, clone. Path. Push. Variable path segment. Struct field. And what we want to return. L value, variable, field path. There's nothing else they want me to add here. Ah. And there we go. That's for single static assignment form stuff. Then here, if this is a pointer, what we want to do is context, emit, IR up, I add, index addition, and then on the left we have the pointer, and on the right we have IR value constant I32 which is a type would be very nice. I'm going to add a type to this. And now we can do type. Oh, we have to make sure the type is a struct first. Let type about a field of non-struct value. Now it could be pointer. So we do need a match on type. And I wish I could match on box as well, because then I could get super fancy and ooh. Actually, we can extract the struct ID regardless. Second, if this is a pointer to a struct, then this is already like this is already struct. Then this type has to be of the inner type. Let's just like say memory address and inner type, specifically the inner type, which I'm probably going to get wrong several times and it's going to be an absolute pain. Oh, I still have it right there. Okay. Okay. Now we can finally emit the I add instruction for okay. Not quite yet. We still need to get the offset, so layout, bit, byte offsets, get index, okay or else. And there we go, we have an offset. Number. Gotten to this point, we've already validated that it has a mover at that offset, type clone. There we go. We have a severely over-engineered get struct field function that works for all L values. Means we can finally go back to the store operation. Say for field in fields store self store and I'm actually going to enumerate and then label, and then value. Destination equals self get struct field L value index context. Self store in the destination. The value field L value. Guest slightly moved, so let's make this a reference. Make a value a reference with no consequences. Cool. That is the better method. Okay, so we just iterate over the struct, store every single one of its values. There we go. That took like an hour. Okay, and then for enum, we just do Yeah, this is the R value. The type is very important here. It is directly the enum. Let's go. Type, layout. Okay, and now that we have the layout, we can just directly store the data at the root indice. So we can store if we have data. We're gonna do self store. Since we don't have type checks, and then we just directly emit variant pointer, which is ir op I add. The left is pointer. The right is IR value, const I32, layout. Index offset as U32, I32. Okay. Variant is just directly an IR value, so we can just drop it in there as the source, throw it into the pointer, and we are good to go. I'm gonna have to do load, won't I? It's gonna be the opposite of this. I wonder... maybe... reference? Store and create. Reference store and IRRS to create a load function that returns a result R value. Okay, it does have some errors. Type. It's a wild card. No. No. Wait, I do have a type. Right there. That's the inner type of the pointer. What? That missing match arm pointer is not covered. Just gonna copy this branch here. And this doesn't matter. And for now, pointers are 32-bit sized integers. Variant deck. Operation load. Yes, I just changed it. Get a pointer. And I can't check the variant index at compile time. There isn't a way. When I'm loading a variant, I need to know exactly what variant is being loaded. Or do I? R value, enum. I don't know what the value is. We don't have any way to know what the value is. Wait a second. Value. Yeah. Whatever the variant is, and whatever the value is. We can't know. We can know the total size of the data. I don't know. I am probably about to dip out. I've hit one of those problems that's like, I'm gonna have to sleep on this. And the problem is, I'm treating this enum variant like I know what it is, but I don't know what it is. And the thing is, I'd have to like do like switch statements and stuff to figure out what it is, because it's compiler. I don't know what the value of this is at runtime. I've been up for like nearly 24 hours at this point, so I just want this to be working. And it's turning out, so far, a lot cleaner than I had hoped for. That is good. Ah, true, there's the load test. I did kind of want to reset my sleep schedule. It's at 6. It's fine. You're right, I do need to like go to sleep right now if I do want to make it to that. Which I should, because I can Donate 8 clients to the cause. Alright. Not to this yet. This madness. I did not ever get around to uploading my avatar. So I'm going to be default avatar. I'm gonna have to figure out how to handle enums without allocating them. Because I have structs figured out. I don't have enums figured out. Because enums, since they can be unions, I don't have those figured out. Without emitting control flow, I can store enum variants just fine. R value can be an enum variant. An L value can be a regular enum. That's probably an important distinction. L value, whole enum. R value, enum variant. Can I go to R value? Hello? Syntax highlighting? There we go. Oh, I actually renamed it enum variant. That's probably one reason why it's kind of bugging. we always know where this value is. Don't know where this value is, or if it even exists. The struct fields will always exist. The answer is going to be casting. Like phi functions. No, it's not handled by a phi function. That's not how that works. I create an R value that's just like unknown. No, because it does need to be something that actually exists. Could also be a pointer. Or block of memory. But it can't really be a block of memory because we need to know exact values. I might need to treat enums as a first class value. To the back end. And then have a specific intermediate code for unwrapping them to certain values, to casting them. Because I'm unsure how to handle. The main problem is that it could contain a struct or it could contain a native value. If it contains a native value, Because there's points at the program where, let's say I'm in a match statement, and on each one of those branches of the match statement, I know exactly which variant the enum is, and I can load those just fine. It's easy. Everywhere else in the program, though, no clue. We kind of do basically always have to pointer allocate enum variants unless they can fit in the size of one value, which means that I would just use the IR value system. I don't know how to handle variants with varying. How handle enum with varying? I'm gonna sleep on this. Yeah, it's time for me to stop the stream. It is time for me to sleep.